All right, part 2 of our annuities examples. So we had example 1 and 2 in part 1, and now we've just got 2 more examples which are just slightly harder. So in this example here, we have when Jill was born, her mother deposited $180 into her trust account, earning 12% per annum with interest compounded annually. She continued to deposit $100, yay, so it's a regular contribution, into this account every time Jill had a birthday. The last payment was made on Jill's 16th birthday. Calculate the total amount in the account on Jill's 25th birthday. So you can see how this is different to the last couple of examples and questions we've done, because this time the last payment is not, on her 24th birthday, it's on her 16th birthday. So there's going to be a couple of years between, on her 17th, 18th, 19th, etc., all of those birthdays, where her mum's not putting in $180 into the account anymore. But all the money that she has put in, all those other regular contributions, are still going to be earning compound interest for that time in between her 16th birthday and her 25th birthday. So let's work it out. If we let A1 be the amount that she puts in the account on her first, not when her first birthday, when she's born, and then we want to see how much that is worth on her 25th birthday. From when she's born to her 25th birthday, that's going to be 25 years. So I've just got that here. So the amount, A1 is the amount that she's born, and in 25 years, that's how much that first amount is going to be worth. Then on her first birthday, this has kind of cut off a couple of words that I wrote on here because I scanned it. On her first birthday, we'll call A2, and then she's putting $180 in there, and then that's going to be in the account earning compound interest for 24 years. On her second birthday, she puts another $180 in, and then that's going to be earning compound interest for 23 years. All the way down to now her 16th birthday, remember, I've just copied a smaller picture. Smaller example of the question over onto the right-hand side here. So last payment's on the 16th birthday. So that's what this last one is. And then this second last one will be her 15th birthday. So on her 16th birthday, you've got the 17th deposit of $180, and that is going to be earning compound interest for 9 years. So that's from her 16th birthday up to her 25th birthday. That's 9 years. And that means the previous deposit of $180 on her 15th birthday would have been earning compound interest for 10 years. So now the question's asking for the total amount in her account on her 25th birthday, which means we need to add up all of these amounts from when she was born to her 16th birthday, and all of the compound interests as well. So when we add all those together, we get this expression when we factorise out the 180 as well. And you can see in brackets here, we have the sum of a GP, where the first term, A, is 1.12 to the power of 9 this time. You can see the common ratio when you divide the second term by the first term is 1.12. And the number of terms, counting from 9 all the way up to 25, and you can see that there's going to be then 17 terms there. And you could also see that from setting up our series here, that there's 17 terms there, all the way down to A17. So, using our sum of a GP formula then, let's find an expression. There it is for A, and then we've got brackets R to the power of N minus 1 on top of R minus 1. And then just putting that in your calculator, you get an amount that's going to be the total amount that's in Jill's account on her 25th birthday. All right, there is another way of working out this question as well, and that's instead of saying the first deposit of $180 is going to be in there for 25 years, let's move that around. You could say that the first deposit, my solution, for 17 years, so from when she's born till her 17th birthday, and then the second deposit on her first birthday will be in there for 16 years. The last payment there of $180, that's on her 16th birthday, and that will be in there for 1 year. If we were to add up all of these amounts then, that'll be the total that is in her account on her 17th birthday. And then that amount you can think of as a lump sum, and that's just then sitting in the bank as a lump sum, earning compound interest for a remaining 8 years until her 25th birthday. And you can see I've just used the compound interest formula then to see what amount will be in the account on the 25th birthday, and you can see it's exactly the same amount that we had from the previous working out. So depending on how you would like to think about setting up the series and approaching it, there's a couple of different ways you can do these kinds of questions. All right, let's have a look at another. So in this example here, we've got when Jack was born, again when he's born, his parents deposit $100 into an account for him. That's nice, at a fixed interest rate of 6% per annum compounded annually. All right, and his parents continued to deposit $100 into his account on each of Jack's birthdays up to and including his 17th birthday. And then when he left school on his 18th birthday, his parents deposited $1,000. So they upped it from $100 every year from when he was born till when he was 17 until, and then on his 18th birthday, they deposited $1,000 into his account. That's pretty nice. So part A showed that the initial deposit of $100 had grown to this amount by Jack's 18th birthday. So that's just a simple compound interest formula. And then part B, calculate the total amount that was in Jack's account when he left school. So remember, when he left school on his 18th birthday. Correct to the nearest dollar. Okay, I've set this one up. So here's the question again for you, just a little bit smaller over here. So when he's born, you got $100 in the account, earning compound interest for 18 years, because that's, remember, when he leaves school is on his 18th birthday. And for part A, you can work that out and you can show that that's equal to 285.43. Then his first birthday, they put another $100 in, that's earning compound interest for 17 years. Second birthday, puts another $100 in, that's earning compound interest for 16 years. All the way down to his 17th birthday, when the parents put in $100, and that's only earning compound interest for 1 year. And then on his 18th birthday, his parents deposit $1,000. That's that $1,000 there on his 18th birthday. But that's not earning any compound interest, because the question is asking for how much is in his account when he leaves school. That's on his 18th birthday. So his parents put the $1,000 in, and then they're like, okay, now how much is in your account? So setting up the sum of all of these amounts, you can see we've got $1,000, which is there, plus $100 times 1.06 to the power of 1, which is that one, all the way up to $100 times 1.06 to the power of 18. We factor out the $100 again. In the brackets here, you can see there's a sum of a GP. The first term is 1.06. Same with the common ratio is also 1.06 when you divide the second term by the first term. The number of terms, you can see with the powers from 1 up to 18. There's 18 terms there. Also, you can see that in our series. Oops, that's going from here to here, 18 terms. And then you can just put that in your calculator, and you can see that that's the amount that Jack this time is going to get in his account on his 18th birthday. And that was it.